like this, what we have here is we have some function f, and they give us the derivative of this function. Now, they want us to determine using the given derivative which of these following statements, and it's just talking about relative minima and relative maxima. Now, what you do here basically is that you want to see this function, and a calculator is allowed, so you could just plug this in and you can see what this function will look like, and then you'll be able to determine all the information that I'm about to get without the calculator. Now, without the calculator, I use the rational roots theorem, or I could just figure out just by telling that 2 makes this derivative equal 0. And with that, I have a root, I have a factor, and then therefore I could factor it. I could use synthetic division. I know 2 is a root. If you do 2 cubed, right, that's 8. Minus 2 times 3 is 6. 8 minus 6 is 2. 2 minus 2 is 0. So I know that that's a root, and then I could use synthetic division to get the quadratic that's left, and I can see if I could factor the quadratic, and I can actually factor this derivative. And I'm going to do that. Okay, so you could see that. If you don't see that, then again, a calculator is allowed. Just graph this function, and you'll get all the information that I'm about to get without using the calculator. 4, 1, 2, 0. Okay? And now I know that x minus 2 is a factor times this quadratic that's left. This is x squared plus 2x plus 1 is equal to this f prime of x and it's equal to the x cubed minus 3x minus 2. And then if you look at this quadratic, what multiplies to 1 but adds to 2? 1 times 1, right? 1 times 1 equals 1, and 1 plus 1 equals 2. So then this whole derivative factors as follows. I have x minus 2 times x plus 1 squared. And now I can tell what the zeros are. And again, if you can't do this, you could just use the graphing calculator, and the graphing calculator will tell you what the zeros are immediately. Now, what we have here is I'm just going to graph out on a number line where these zeros are. So I have at -1 a 0. I have 0 right here. Let's just mark out 0, and then 2. Sorry, let me put 2 in a better spot. 1, 2. And my derivative equals 0 at -1 and 2. And basically, if I know a little bit of pre-cal, I can graph this again, but again, you can just use the calculator. You'll see that since it's a double root, the power is even. That means, and it's a cubic. So if I were to graph this original derivative, this function here, and if I were to use my pre-cal abilities, I would know that it's a cubic. So it starts off very negative, and it comes up, and the first time it hits the x-axis is at -1. But since it's a double root, since that the multiplicity is even, it just kisses and goes back down. Then it's going to come back up, and it's going to go through at 2 because its multiplicity is odd. It's just 1. And this is what my derivative will look like. And again, you can just use a graphing calculator to get what this shape generally looks like, and you'd be up to where I am right now if you just immediately graphed it. But now we're here. Now we know what this derivative looks like in full. Now we can get what f looks like. So we need to know that our original f is going to be, so this is the x-axis, our original f is going to be decreasing where this is negative. So f is decreasing, 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 and then it stops decreasing here, but then it goes back down and it just continues to decrease. So it flattens out at -1, but then it keeps decreasing, 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 until right here at 0 again, it flattens out and then it begins to increase. And this light blue one is a graph for f. And I have this point right here as my only relative minima. My relative minimum. My relative min. And that's it. So let's see. It has no relative minima and one relative maximum. No, it has one relative minimum and no relative maximum. That's exactly correct. There's no point where it's a relative maximum. This point right here, it flattens out, but then it continues to go down because the derivative only kisses. So it doesn't go through, right? Where the derivative is negative, the function is decreasing. So it's negative, negative, so the function is decreasing, 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 decreasing. It's negative, negative, negative. It goes to 0. That means it's not decreasing or increasing. It flattens out. The slope of the tangent line right there is 0. And then it just goes back down, so the derivative is negative still, so my function is still decreasing, decreasing, decreasing until it gets to this point 2, where it crosses and then it begins to increase.